Someone please confirm if you're able to see the slides, because it was showing your connection has lost, something like that.
Yes, sir.
Okay. Thank you, Prem. So, moving on, you have two pilot signals coming here. The left one I'm drawing first because that is operated, that is based on the manual operation. So over here we will be having the push button actuated 2x2 DCV. Now from here you have to make the flow happen through a time delay valve, right? So as I showed how it looks like, same thing. Maybe one check valve, then one accumulator, then one pilot operator, 2x2 DCV, spring return type. Again, this is the pressure port and this is the exhaust port. And from here, your outlet is coming. So that outlet will be connected to this particular line. Again, this will be dotted because there is no fluid coming here. So dotted basically means there is no fluid flow in that line. Okay. But that connection is there. Once fluid flow will be happening, that line will be formed line. Now all the pressure ports you are having. So this is generally enclosed within box. Okay. Now all the pressure ports that you are having, pressure lines here, 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 and here, they are connected together. Connected together, and they are receiving flow from power source via a filter, regulator, and lubricator. Okay. Now just let's try to analyze this. I'm again saying that I will do it using that red ink, but that is not a proper way. You have to show a different circuit if you want to analyze. So what will happen? Your flow will be coming like this. It will come here, and this particular configuration will be activated, and the flow will come to this port here, say X. This was Y. So what will happen? This, as soon as it comes here, this particular configuration will get activated. So now the pump sorry, not pump. It will be like from the compressor rather, not like P is from the power source, not pump. P means power source. If I have said pump in the previous questions, please ignore that. It should be from the power source. Okay. Now this will be your P line. The flow will come here, then to this side of the cylinder. It will push the cylinder, and the air that is present on this side will be ejected through this port to the exhaust valve. Okay. So this will be happening till when? Till this thing touches S1. So as soon as it touches S1, you have to ensure that you release this particular plunger T1. Otherwise, again, signal conflict will happen here. If both the X and Y signals are coming to the valve, there will be signal conflict. Now, the extension stroke happened, A plus happened, it has reached S1 and it has touched S1, and you have released T1. So we will now draw that particular configuration. What will happen at that particular point of time? You have released T1. So when you have released T1, this configuration will again come into picture. So now here there will be no fluid power pilot signal here, but as S1 is getting activated, this particular port will, I'm showing with green color, this particular configuration will get activated. So now it will receive the flow from power here, will go through here, and from here it will move into the time delay valve. So TDV I'm writing, this is the time delay valve. So it will pass through, it will not be able to pass through this NRV, it will rather pass through this choke check valve, and then it will fill up the accumulator. Okay, it will fill up the accumulator. Based on the size of the accumulator, it will take some time, say 5 seconds or 10 seconds. So that particular time is the delay. So your accumulator is designed accordingly. After the accumulator is filled, it will go and send the pilot signal here. As soon as this particular valve gets a pilot signal here, this configuration will get activated. Now what will happen? Now the pump flow will be happening from here to this port, and it will go to here. After, mind you, after that 5-second delay, this will be happening. It will come here. Once this is coming, since this is already deactivated, this port, this configuration will be activated, and as usual, this pump flow will be coming from here, will be going to B, and it will push here. Now the retraction starts happening. So from this position, say from the extreme position, now the retraction will start happening. Now the retraction will start happening. Okay, once the retraction starts happening, it will release the S1 switch, right? S1 switch is released. Now what will happen? Now it will return back to what I had drawn previously. Like there is no, this S1 is released. There will be no pilot signal here. So what it will resume back the previous configurations. So this is the old configuration that will be resumed. Okay. Now this particular 5 by 3 DCV, this is also known as 5 by 3 direction control valve. It is also known as memory valve. Why? Because it will retain the position. It will retain the last configuration what it was holding. So even if it is not receiving any pilot signal from here, this Y, still it will resume this particular configuration and it will take up the flow from P port to B port and it will allow the exhaust to happen. Okay. So this is how the circuit works. While explaining all these things, if like generally if you are asked to draw the circuit, then you will draw only the return line, whatever I have shown now. If the question asks you to analyze it, then you have to draw the extension circuit also and accordingly show what is happening. Once you are pressing the plunger T1, what is happening? When it reaches S1, what is happening? So now what was left here, you just have to label the components. Say this is 1.1, 1.2. This entire I am writing as 1.3. This entire 1.3 is a time delay valve. So while labeling time delay valve, I am showing you and 0.1. So while labeling here, say 1.1, 1.2. So 1.3, you have to write time delay valve. In bracket, what is the duration? It will be asked in the it can be said in the question like for a defined time 5 seconds, 10 seconds. So that you have to write in 10 seconds. That is the proper way of denoting the time delay valve. How much time delay is happening? Okay. So it's done now. Any questions regarding this circuit? Prem, Swachita, any questions if you're having, please unmute. You can ask. Okay, then proceeding to the next question. So another, yeah, Prem, you are supposed to ask something.
So yes, sir, but not regarding this question. Sir, can we access the slide ups from Sekar, sir? Can we found anywhere the slide ups from Sekar, sir? Our course faculty.
Slides means you are already getting the videos, right? So
yes. Actually, I have gone through the video.
I don't think the slides will be available.
Okay.
I don't think the slides are there. But yeah, you can get the transcripts from NPTEL. Transcripts, like whatever sir is speaking, that is getting converted into a documented file, and that you can access. I think transcripts are there for this course, so you can check once. Okay.
Okay, sir. Thank you.
Okay. Coming to the next question, draw a pneumatic circuit to control a large bore double acting cylinder with simultaneous pushing of two push button actuated valves for extension and another push button actuated valve for retraction. So what is it telling? It is telling that when you are simultaneously actuating two push button actuated valves, then it will extend. Then once the extension has happened, when you push another push button valve, it will retract. So why do you think this may be necessary? Like why two push button valves are needed for actuation? Incorporated for added safety. So suppose some heavy operation is there, so already it is saying a large bore double acting cylinder, so you can understand it's a heavy duty operation. So there, as a extra point of safety, you can add two push button switches. So suppose one is foot operated, another is hand operated, or both can be hand operated. Using both hands, you will be doing it like that. It can be there. Okay, so anyway, let's try to design the circuit. It's a simple problem, but as the question says that simultaneously two there has to be flow from two points simultaneously. What should come into your mind? There should be some sort of valve which will open the output port when both the input ports are high. High means both are receiving flow. So there should be some sort of valve whose output Y will be 1 when both x1 and x2 is 1. So it will act like a AND gate. So when both x1 and x2 is receiving flow, only then Y will give out the flow. Or else it will not operate. Okay. So you have a large bore double acting cylinder. So you can show the load by a trapezoidal element here. Next, it needs to be operated by a pilot operated valve. Generally, we use pilot operated valve because whatever signal you are getting that is coming as an output as a, like whatever is the input to this particular valve is an output from that AND gate or and like the valve that is simulating your AND gate. Okay, so we will be drawing the retraction configurations. So this is your P, and you have the two exhaust ports here. So this is the pilot signal for the extension operation. So extension will happen only when both the signals you're getting flow from both the plungers. I mean both the plunger actuated valves. So there will be some AND gate as I showed. So this is how it looks like. It will receive flow from both sides. Okay. Say you can just number this 1113 like that or 1214 like that, and accordingly it will give an output say 2, or you can just give alphabetical notations also. I'm skipping that as of now. So during your retraction operation, none of this will be receiving the flow. So I will do that as a dotted line, and these two will be connected to the two plunger. Sorry, two push button actuated valves, not plunger. Okay. Um, so this is your P1. Accordingly, there has to be another P2. And during the during the extension, there will be another push button which alone will be actuating your return stroke. So that will be directly connected to another push button valve. Return stroke is happening, so this should be not dotted line, rather it should be firm line. Okay. And all these power ports, P ports will be connected to your power source via the filter regulator and lubricator. That's it. Now, just one thing that I missed here. So that may come to your mind that is not compulsorily asked in the question, since it is saying that it's a indirect implication. It's telling a large bore double acting cylinder. So large bore double acting cylinder means generally they are heavy duty cylinders, and like they are associated with high energy tasks. Okay. So in such circumstances, you don't want the cylinder extension or the cylinder retraction to be happening very fast. As soon as the load is removed, it shouldn't be, the retraction shouldn't be very fast. Okay, generally I'm telling. So in that case, what you can do is you can put a check valve here, choke valve with mm, a non NRV, so that will. So what will that do? It will facilitate controlled flow through this line. Okay. Sorry. Here the retraction stroke won't be controlled. Rather, the extension stroke will be controlled. So I'm extremely sorry. Since it's a large bore double acting cylinder, it's carrying some heavy load, say, for a large heavy duty application. So your extension stroke should be happening in a very controlled way. It shouldn't be very abrupt. So that's why we generally put this mm, flow regulator, flow control valve, say. And what will happen during the extension stroke? This particular configuration will be active, and from here it will go to here, and the exhaust will be happening through this flow control valve. Okay. So as a result, it will be happening very slowly, and then it will exhaust out. So your extension will be controlled extension. It won't be very abrupt. So this is just an add-on. It is not compulsory, but intuitively it should be coming to your mind while designing the circuit. Sorry. I'm just putting this here. Okay. So what am I left with? It's an important thing. So I have to light the signals here. You can write numerics also, like 1, 2, 1, 4, like that also. That is also preferred. And one more important thing is valves. And as I said, the left and bottom side, you have to mention what are these. What is 1.1, what is 1. Okay, I think we are done with the circuits. Now, just a few more theoretical questions and we will wind up the class. The signal flow direction is in the order. So whenever you're designing any hydraulic or pneumatic circuit, there should be a designated flow while you are while you are breaking down a particular control chain. So in case of signal flow, what is that particular you know particular sequence rather? So when you are doing the breakdown before designing any circuit, you should be doing that breakdown. So in that case, you have to do this signal flow line or the workflow that you have to arrange. So first, there should be some power source, obviously. So first is main thing is your power source. It shouldn't start from any signal elements or drive elements. It should start with power source and it should end with actuating devices or the driving elements. Okay. So V and E satisfies both of those, but in between you have to see what is there. So after the power source, there has to be some switches or push buttons or some limit switches. All those things are signal elements. Okay, so those come under the category of signal elements. So after power source, next is your signal elements. After that, what comes in the hardware arrangement? It comes with processing elements. So under processing elements, you will be having different types of valves. So they're actuated by some they can be like some pressure relief valve, or it can be some non-return valve. Like there are different types of valves that are actuated by some pressure. So those things will be coming as a part of the processing elements. Then after these pressure control valves or pressure related valves, what will come is your direction control valve, right? So direction control valve will be determining what will be the flow, what will be the sequence of operation of the elements, of the final drive elements, like whether it will be extending or retracting. So all those things will be coming under the direction control valves. It may not be 5x2, it can be some other direction control valves, but yeah. Next, finally, you will have your actuating devices or the drive elements. It can be cylinders, motors, or it can be like some modular units also. Okay. So this is your correct option. These are not air-powered hand tools. So as you know that there are many air-powered hand tools in the market which are being used for different day-to-day operations, either in the industry or in commercial or household applications. Impact wrenches are air-powered tools. Diaphragm cylinder, it is not a hand tool. Then rivet cutter, it is a hand tool. Jackhammer is also a hand tool. Bellow actuator, it is a air-powered tool, but it is not a hand tool. Okay, so these two are not air-powered hand tools. So since these are multiple answer type MCQs, so you have to be very careful about this thing. Suppose you would have skipped this knot, you would have like this is just a simple example I'm giving. You would have ticked A, C, D, then the answer would be wrong. So MCQs will be there in your question paper. In that case, you should be careful about what the question is asking. Okay, so draw the symbol of a 5x2 direction control valve, direction control double pilot valve. So it's simple. We already have seen in previous questions. So there will be how many ports? 5 ports. So your A and B port are there. Out of which one will be connected to pressure port, other will be exhaust port. And there is another port here that is also exhaust port. Similarly, this is one configuration. What will be the other configuration? Your P will be connected to A B will be connected to exhaust, and another exhaust for A will be blocked. Apart from this, there are pilot signals which will be coming from both sides, like this. Okay. So based on the pilot signal, your which configuration will be taken up, that will be decided. Suppose you are getting pilot signal from here, then this configuration will be taken up. So this will be the lines accordingly. So if you are asked to draw the direction, the symbol, then this is the symbol. You have to label this XY or X1, X, whatever. Okay. Now, how many ports are there? Is it like there are two 5x2 means? What does this 5 and 2 represent? 2 represents how many configurations? Do you have any question? Okay.
No,
And 5? Yes. Please. Hello?
so actually that I'm telling five means 5 ports and 2 means the 2 configuration. Like in one configuration we have to have 5 ports, in another configuration we have to have another 5 ports. Okay.
See, this is one configuration. So I am just drawing it once again. This is my valve. Here 2 means 2 configurations. This is one configuration, this is one so I am partitioning the box in a big box into 2 smaller boxes. So they represent the 2 port positions. Like it will be either this one or this one. Okay. So suppose it is this, the right configuration it is holding. So when it will hold, when your pilot signal will be coming from here, and when there is no pilot signal from here, then it will hold this configuration. When it will be the other way around, suppose there is no pilot signal coming from the right side, but there is pilot signal coming from the left side, then it will hold this configuration. It will not hold this configuration. Okay, so configuration means how the ports are connected. So port means basically there will be some pressurized fluid coming from here, from the power source, and that will be disbursed into the cylinder on both sides of double acting cylinders or on single side of single acting cylinder. So accordingly, if you just try to design or draw 5x2 DCV, it will be like this. So there will be one pressure port which will be connected to your B port. B means if this is your cylinder, there will be 2 ports from in double acting cylinder. One is A, one is B. So this B will be connected to here, and A will be connected to here. So for exhaust stroke, generally it is like this. And the other exhaust port, as I said, it will be connected to your So this is one configuration that I have drawn. What will be the other configuration? Other configuration is P will be connected to A, that is your A port is receiving the flow, while B port will be drawn to the exhaust line. Okay. So this is the other configuration. At that time, the particular port, the exhaust port, which is corresponding to A line, will be closed. So when you are drawing a particular valve, only one configuration will be active. The other configuration will be inactive. Okay. So there you need not draw you need not write the port names. That is A, B, C, D need not be mentioned. It will be mentioned only on that side where it is connected. So yeah, this is how it looks like 5 by 2 DCB. Why now the main where this number 5 is coming from. So 5 is basically number of ports, right? So where you are seeing 5 ports, you can ask there are say for any one configuration there are how many ports? A, B, E, P, E, X and Y. So 1, 2, 3, 4, 5, 6, 7 ports are visible here, but you are writing 5 ports. Why? See here both these E ports are same, and both these X and Y ports are pilot ports. So they are considered as single ports. So both these E ports will be considered as single, one particular port. Both these X and Y are pilot ports, they will be considered as a single port. So now you have A, B, P, 3 ports, then one exhaust and one pilot. So total 5. Okay. You have understood this, Swachita?
Yes, sir. I understood.
So, okay. Now, what is the next question? Why are they referred as memory valves? So, I already discussed it in one of the previous questions that suppose when it is receiving a signal from suppose it is receiving a particular pilot signal from either X or Y. Suppose it is receiving from Y, then this configuration will get activated. This is the partition line I am drawing in bold. Okay. So the right side, this configuration is getting activated. So now what will happen? Now the flow will be taking place from the pressure line to the B port, and from the A port to the exhaust line. It will be okay. So just give me 1 second. Now suppose you are cutting off this Y signal, like your operation is over, you are cutting off the flow to the pilot line Y. Okay, now what will happen? There will be no it's the 5th time it is happening actually. Sorry for the interruptions. Now see like whenever you are receiving signals from whenever you're not receiving any signal from either of the ports X or Y, then what will happen? Then it will resume whatever previous configuration it was having. So it was having this particular configuration, it will hold that particular position only. So your flow will be happening from P to B and A to E. Okay, suppose it was retracting, the cylinder was retracting. So this is your valve. So this was connected to exhaust port, P port was connected to B port. So now there is no signal here, but previously, as I said, there was some signal over here. Okay, so now as soon as that signal is cut off, this configuration will be held and the flow will be happening from P to B, and the cylinder would have been retracting, although there was no pilot signal here presently, but previously it was there. Okay, so that's why we call it memory valve. It is having some sort of memory, like it is operating in such a way that it implicates it is having some sort of memory. It is memorizing the previous configuration and holding that. So that's why it is called as a memory valve. So this is just a short answer type question that you may expect. And next is, what is the challenge of using this valve? Now see, as I said, that this valve can assume either this configuration where P is connected to A and B is connected to exhaust, or this configuration where P is connected to B and A is connected to E, right? What if both of these pilot ports are receiving some flow, some sort of signals? Signal here means fluid power signals. That is, there will be some sort of flow, air flow happening here or fluid flow happening from both the ports. Then what will happen? Then this particular valve will be in a state of confusion. It can't assume this position, it can't assume this position either. So that's why that is called signal conflict. Okay. So professor has beautifully explained this using multiple circuits, wherein you are having like two cylinders, where the extension of one cylinder, upon reaching its extended position, it will activate the extension of another cylinder. So suppose there is an operation wherein one cylinder A will extend from say A0 position to A1 position. A1 position is the extreme extended position. So once this is reached, another cylinder B will be extending from B0 to say B1 position. As soon as it reaches B1, again this particular cylinder, as soon as it reaches B1, it will retract back, and again when it retracts back to B0 position, this cylinder, which that is A, will retract back to A0 position. So basically, if I just plus means extension, minus means retraction. So A plus means the cylinder A has extended. Next, as soon as it reaches the extended position, your B cylinder has extended, say B plus. Once B has extended and reached the B1 position, it has done some operation, say some punching operation or drilling operation, then it will retract B minus. So once it has retracted to B0, again A cylinder, which was extended till now, will start retracting from A1 to A0. So you can understand that this A1 position, there will be some limit switch that will activate the B cylinder. Again, when B is retracting back to B0, this will actuate this particular retraction stroke. Okay, so the extension stroke of B cylinder is activated by A1, the signal from A1, and the retraction stroke of cylinder A is activated by the signal B0. Okay, so there are possible chances of signal conflicts here if you are using this type of 5x2 DCV, wherein both the ports will be receiving the flow. So you can go through the videos for better understanding. Due to time shortage, I will not be explaining that, and already professor has explained it very extensively. So in such cases, signal conflict will happen, and that is what is a challenge using this valve. So this valve can't assume like whenever it is receiving flow from both the ports, it will be in a state of confusion. So how to overcome that? That is the next question. The following valves have been devised to overcome the problem of signal conflicts. Idle return roller valve. So this is a particular type of valve where what happens, suppose this is your cylinder. So whenever it is going and suppose this is your A0 position, this is A1 position. So whenever it is going to A1, there will be some sort of valve that will activate the extension stroke of B cylinder. Okay. So again, it's two positions are B0 and B1. So at A1 you will be placing one limit switch. So that limit switch is basically a switch for the valve that is extending or actuating this cylinder B. Okay, so that particular valve is a idle return roller valve. So what will it do? It actually looks like, suppose this is the rod of your cylinder A and this is your idle return roller valve, say. Okay, so once this has extended, it will just activate B, and again like this particular this particular switch or the roller will get activated and again get deactivated. So if you look at the signal, it will be looking like this. So this is the activation point where this roller valve is getting activated. And as I said, this type of valves are memory valves. So whatever was this particular activation position, that will be held, and it will allow the extension, like the next sequence of operation that is happening, that will be initiated. And once again when it is coming back, say, this will again activate it, and again like this will act like a push button switch. Okay, so as soon as it touches here, it will push it, and again as it rolls over, that switch will get deactivated. And on the return side also, so that's why it is called idle return. So it will just activate the switch and again come back. So at that time it will be in idle state. So that's why idle return roller valve. Next, logic valve. No, logic valve is not used for this. Logic valve is the AND valve and the OR type of operations that we had seen today. Those valves are logic valves. Memory valve, yes, memory valve can be used. Shuttle valve, no. 4x3 DCV, no. So another way that can be used to overcome this problem of signal conflict is by using cascading. So cascading basically means whatever operation that you're having. So this is the operation, sequence of operation. So how you're arriving here? You're arriving here by like on the basis of whatever operation you are doing. Suppose I am just citing one example of shop floor, wherein you are doing some sort of drilling operation, drilling of a particular workpiece. So what you are having one cylinder which is having the workpiece. So this is your workpiece, say the shaded one, clamped. Okay, so what it will do, it will extend and bring this to a particular position, say here. So as soon as it has brought here, there will be another cylinder that will go and clamp this. The clamping, it can be a clamping or it can be, say, a punching operation. Let's say it's a punching operation, not a drilling, rather than that punching operation. So in case of punching operation, you will have a punch here, and this was the die, and you have the workpiece. So it will come down, it will punch it, it will make a hole here. Now you are left out with this thing, right? So now what is the picture now? Once it has punched and gone up, this cylinder is still in the extended position with the punched workpiece, right? Now there has to be some ejector tool. Okay, so this cylinder has gone up. Now there should be some sort of ejector, say here, that is also operated by another pneumatic cylinder. that will simply go and eject this particular workpiece out, and it will fall into some other tray or trolley that is present in the vicinity. So as you can understand, if you just try to model this into, so this is say cylinder A, this is cylinder B, and this is cylinder C. So first cylinder A will extend. So that's why I'm telling A plus. So once it has extended, that extended position, A1 position, it will automatically trigger the extension of B. So now B1. So this operation was triggered like from that B plus is triggered by A1 signal. Okay. Now B plus, as soon as it as the cylinder reaches its extended position, it does the punching operation. It will immediately retract back. So B1 position will be triggering this retraction. So B minus is the retraction. So once it has retracted, now your this ejector cylinder, that is cylinder C, will be getting activated. So C plus will be triggered by B naught, that is the extended position of B. So once C plus has done, that is it has extended, it has ejected it out, it will again retract back. So that is C minus. So that is again activated by C1, right? Yeah, be careful about what signal is activating the position. So this A plus, B plus, these are basically operations, and this on the top I am writing A1, B1, B naught. They are this particular positions that I showed here. But did I show? I think anyway, I'm just writing here. So suppose this is one cylinder. So this is your, if this is cylinder A naught is the initial position, A1 is the final position, retracted end position and extended end positions. So once C minus has like C has retracted that, what will it do? It will reach C naught. So that will trigger A minus, that is the retraction of A. So this is your sequence of operation for this entire for this entire hydraulic circuit, not hydraulic, sorry, fluid power circuit. So this is the set of operation. Now you have to group these operations in such a way that extension and retraction of any particular cylinder. So each cylinder will be activated. Say this A cylinder will be activated by a valve. B cylinder will be activated by another valve. C cylinder will be activated by another valve. Right? So its extension and retraction will be decided by the configuration of that valve. So if that valve is a pilot operated valve like this, so there shouldn't be any instance where it will be receiving the flow from both the sides of the pilot line. So to avoid that, you have to group these operations into multiple small like multiple subgroups, wherein there shouldn't be conflicting operations. Suppose there shouldn't be any group which contains both the plus and the minus for a single cylinder. So A plus and A minus shouldn't be grouped into one group. B plus, B minus shouldn't be present in one group. C plus, C minus shouldn't be present in one group. So to fulfill that, what we will do, A plus and B plus we will do in one group. Say G1. Grouping I'm doing. B minus C plus won't cause conflict, so that can be grouped into another group, say G2. C minus, A minus, they can be grouped into another group, G3. Okay, so this is like G1, G2, G3, G1, G2, G3. Like this, this operation will be happening for multiple iterations, for multiple like sequential production line. So this is how the entire cascading operations takes place. There are like the circuits, how the circuit will be designed, that has already been explained by Professor. So you can go through that. How for three groupings, for two groupings, for four groupings, how the circuit looks like. So cascading helps you to avoid such type of signal conflicts, even while you are using the pilot operated 5x3 DCVs. But there are some challenges associated with cascading operations. So what are those challenges? If you have gone through the videos, you will be able to recollect. So first of all, as you are seeing that we are doing so many groupings. So each grouping will be associated with more number of valves. These groups are like there are transmission lines in electricity. So these groups are like transmission lines in um, hydraulics or pneumatics, say, fluid power. So either one of the groups will be activated at any instant of time. There can't be any two groups that is activated. There can be only one group that is activated, and that's why I am denoting only one line as firm line and the other two lines as dotted lines. So how to achieve this? And how to achieve this at a given sequence? So after G1, say G2 is happening. After G2, G3 is happening. So for that, we have to use more number of valves, more number of pilot operated DCVs. Okay. So that is one challenge, that your cost increases because more number of, or I would rather write additional direction control valves. And direction control valves are expensive devices. They are not very cheap. They are built on close tolerances, sliding cards. So obviously they are very expensive. So one is that. Next is, in each valve there will be some sort of pressure drop happening, because valves are basically restricting the flow. It is either diverting, or it is stopping the flow, or it is controlling the flow, like reducing the discharge. So it is basically causing restriction. So how is it causing restriction? It will be causing some pressure drop across each valve. So as you are cascading, you are adding more number of valves. Along with the number of valves, you are also adding conduit lines, that is the hydraulic transmission lines, so the pipes and all. So there are also some additional pressure drops are happening. We have solved numericals based on that in the previous session. So that pressure drop is happening. So this pressure drop is high. Third thing in cascading, so as I had shown in that grouping, that A plus B minus A minus. So there, suppose in this particular operation, so it should be grouped like A plus and B plus should be in one group, B minus and A minus in one group. Since this type of operations are happening one after the another subsequently, so obviously after G2 there has to be some means to again bring it back to G1, right? So you should always set to the last group for starting up. Suppose there are three groups, as I had shown there: A plus B minus, C plus C minus, A minus. So here we had that operation that I had shown a couple of minutes back. So here we have three groups: G1, G2, G3. So you should always set it to G3 for starting up this entire circuit. Okay. So that is another thing. Like it is not a challenge, but it needs to be like kept in mind. You just can't leave it at G2. That is, your cylinder can't be extended. That punching cylinder can't be in an extended position in the intermediate line. So suppose there is some breakdown happening, some power breakdown happening, you should have some backup means to bring the cylinders back to the G3 configuration or G3 group configuration. So setting to the last group for startup. Okay, so these three are the main challenges of cascading in fluid power circuit design. Okay, I think that's all for today's session. If you're having any doubts, you can unmute and ask.
No, sir. I have clearly understood the question.
Okay. Thank you. So, are you attending the exam? This particular exam?
Yeah. Yes, sir. I'm attending the exam. Okay. It is
what
next
is the
Saturday.
date? It is next Saturday,
it will be
right?
on next Saturday. It's 20th April.
Okay. So all the best. Like I will try to do one more session like 11 and 12 where I will try to include the remaining topics, or else like it's best if you just go through the videos and attempt the assignment questions. Uh, okay. Okay, then let's wind up today's session. Yes,
So
yes,
like
please.
these are the like we are having assignment questions and in this class also some assignment questions and some other questions also present, na, sir. So can we consider like important questions all these?
Yes, you can expect this type of questions in your exam. Okay, so like assignment questions are mostly MCQ type questions. So uh, like some of them are obviously numerical type also, but most of them are MCQs. So how to solve them? It sometimes it can so happen that while solving all the questions you are not able to do it correctly, but the steps are correct. Okay, so you may not arrive at the correct option, but your steps are correct. So in that case, will be considered for some marking, right? So such things, um, like your approach of solving the questions is what we are trying to see.
Okay,
Okay.
sir. Yeah, okay, sir. Understood.
Yeah. Okay. Thank you.
Thank you so much, sir.